Hey guys, Miss Nguyen here with our Dilations notes. This is the last of our 4 transformations, right? So we have covered up until now translations, reflections, and rotations. Those are each things that really change the figure, either its position, which way it's pointing, stuff like that. A dilation is kind of different. When you hear the word dilation, most people, the main thing they think of is like pupils dilating. So like when you go to the optometrist and they have to check for glaucoma, they put those drops in your eyes that make your pupils dilate so they can look inside of your eye. And so that's a big thing. You can't really see for a little while after that. It's kind of annoying. Or some animals like cats, for example, their pupils get really big or really small when there's more light or less light. So usually when you hear the word dilate, it has to do with eyes in real life, right? So a dilation, similarly, a dilation in transformations is one where a figure is changing in size, right? So either it is enlarged, which means that it's getting bigger. You enlarge, it has the word large in it, so enlarge means it's getting bigger. Or reduced. You are reducing something, it is getting smaller in size. Like, reduce, reuse, recycle. Reduce means you want to use less, have less trash, reduce your amount of trash. Okay? So dilations create a pair of similar figures, which we've covered before. The important thing to note here is that similar figures are not congruent. So this is the one transformation that does not preserve congruency. Okay? The pre-image and the image are not congruent, but they are similar, which means they are proportional. Okay? So we have these 2 pictures here, so you can see it a little bit better. So on the left and the right, our pre-image is in orange. You can also tell because they do not have little prime markings. So here's our pre-image, here in orange, and here in orange, right? So one of the ways that you can check to see whether or not a figure is enlarging or reducing is you can pick the points on the pre-image and draw an arrow from the pre-image point to the image point. So like B to B prime here, A to A prime, C to C prime. If the arrow is going outwards, that means the figure is getting bigger. In this case it is, so this is an enlargement. Okay. Meanwhile, our picture on the right, in blue, this is our image. In blue. Well, this time around, we go. The points are not going out anymore, they're going in. Inside. So that means that this is a reduction. I think most of you can tell just by looking at it, but just in case you're second-guessing yourself, you can draw the little arrows to help you. Okay? So those are the 2 types of dilations, an enlargement or a reduction. Okay? So something that we're dealing with here is a scale factor, which we've covered this in the past, but anyway, we'll talk about it a little bit more today. A scale factor, which we represent with the letter K, shows whether the figure, how much the figure will enlarge or reduce in size. Oops, let me go back to my orange. How much the figure will enlarge or reduce in size. So there's something that we call the nu strategy. To figure out the scale factor, you take the nu, its side length, and divide it by the original side length. That will find us the scale factor. And we've done this in the past with similar figures. This was a while ago. Okay, well, if we're on the coordinate plane, we need to pick a pair of corresponding vertices instead, since we can't really be counting up all those side lengths. No, more on that in a little bit. Okay, if K is greater than 1, then the dilation is an enlargement. That makes sense, because if you say something is 2 times, 2 times bigger, right, wouldn't say 2 times smaller. So if the scale factor is 2, it's getting bigger. It's an enlargement. Whereas if k is less than 1, the dilation is a reduction. So like 1/3, 0.2, stuff like that. That means it's getting smaller. Because if you have half of something, then you have less of it, right? So less than 1 means it's a reduction. Okay? So now we get to our algebraic rule. Easy peasy. It is, with xy as our original coordinate, then it becomes kx, ky, where k is the scale factor. So this one is relatively easy in that all you have to do is you take whatever the scale factor is, you multiply it by x, you multiply it by y, bam, there's your new point. That simple. It's kind of a nice breath of fresh air after rotations being so different. Okay, well, so now let's jump straight into some practice problems. Okay, so for these problems, we are trying to find the scale factor. Step 1, we want to read the problem to identify the pre-image and the image. Pre-image means new, image means original. Okay, so it says ABCD was dilated. So since ABCD was the one that was dilated, that means that ABCD is the pre-image, because it then forms EFGH. This is the image. The pre-image is the one that gets dilated. What you get after, like the new, that's the image. And so this is important because sometimes with dilations like this, you don't have prime marks. They'll say like ABC became DEF or something, you know. So you gotta watch out for it. Okay, so that means this is the original, and this is the new. The original is not always going to be on the left, so again, you really have to read and pay attention. Okay, so what we're going to do now is use the no strategy to find the scale factor by dividing the pre-image side by the image side, or like the new side by the original side. This is where you want to make sure you use corresponding sides. So like this side and this side are congruent. This side and this side are congruent. But if you try to set it up with like 30 and 5 and 25 and 6, you're going to get something really weird. So please make sure you're using corresponding sides. Okay. So K is new divided by original. So we're just going to pick a pair of sides. I'm going to go with 30 and 6, I guess. So 30 is from the new. The original side that goes with 30 is 6. 30 divided by 6 gives us 5. So the scale factor is 5. Right? So if we were to rewrite this as an algebraic rule, we start off with x, y, and the arrow. Okay, kx, ky. This time k is 5, so this is 5x, 5y. All there is to it. Then is it an enlargement or reduction? Well, this is where you consider, this is our step 4. Consider, is the scale factor greater than or less than 1? Because that determines whether it's a reduction or an enlargement. Reduction means that k is less than 1. Enlargement, k is greater than 1. Is 5 greater than 1? Yes. So this is an enlargement. Okay. All right. Number 2. Let's get number 2. Okay, it says a rectangle QRST was dilated. So again, step 1 is to read it. QRST is our pre-image. MNOP is our image. See, this is where you have to be careful because QRST is on the right. So if you didn't read the problem and you were just like, oh yeah, I'm just not going to read that, I'm just going to look at the pictures, you would get it wrong because you would have the wrong setup. This is where it's very important to read the problem. Okay, step 2, use the no strategy. So this is where we need corresponding sides, okay? Like this 21 does not correspond with 56. Why? Because it got rotated. The shape. Okay, 56 is the long side of that rectangle. You want the short side to go with 21. So 21 goes with 14. 56 goes with 84. So corresponding sides means the sides that are proportional. It's very important. So we're going to set this up. K is the new divided by the original. Okay, So you can use 56, I guess. So 56. So the corresponding side on the original is 84. So this is 56 divided by 84. This is where Desmos comes in handy. Okay, already forgot what it was. 56 divided by 84. Here's our fraction. 56 divided by 84. And if you hit this fraction button, it reduces the fraction into 2/3. You can leave it like that. The rule of thumb is if your answer is a fraction, leave it as a fraction. But if you are working with fractions, like you need to multiply them and stuff, then yeah, you can change those into decimals. But if your answer is a fraction, you should usually leave it alone. Because if you were to change this into a decimal, you might not be able to find the answer. You know what I mean? Then step 3, we're going to use that to write our algebraic rule. So our k is 2/3, so our rule becomes xy turns into 2/3 x, comma, 2/3 y. Last step, is it an enlargement or reduction? Okay, well, 2/3 is less than 1, so this is a reduction. Okay, so I want you guys to do number 3 on your own. Same thing here, same steps right here. Scroll up, read the problem, use the no strategy, write the rule, and then is the scale factor bigger or less than 1? Not too bad. Okay, let's look at the next type of problem. These are ones where we're trying to figure out what the rule is. Okay, so we are trying to find scale factor and everything, except this time, instead of a shape, we have our coordinate grid. Okay, so step 1, we want to pick 2 corresponding points. Before we were picking corresponding sides, now we are picking corresponding sides. Sorry, corresponding points. We had corresponding sides. Now we're using corresponding points. These corresponding points need to have matching letters. So A and A prime, or B and B prime, but don't try to go from A to B prime because you will get something very weird. Okay, so in this one, let's use A and A prime, I guess, so we'll use here A and A prime. So first thing we need is we need our coordinates. Okay, well the strategy is that the new one is divided by the old one. So that means let's go ahead and get the coordinates for A prime first, because then when it's lined up, it's just a little easier to deal with that way. Okay, so A prime looks like x is -3, y is -2. A is here, x is -6, y is -4. Okay? So step 2 is we are going to use the no strategy, same as earlier, no strategy. I don't know why it keeps doing that. No strategy. To find the scale factor by dividing either the x values or the y values. So we do not do both, because you're going to get the same number anyway. This is x, this is y. I'm just going to choose y because I feel like it's easier to deal with. So here's our y. So k is the new divided by original, which is the same as saying a prime divided by a. That's why I wanted to line it up like that. So this is -2 is the a prime y, and -4 is the b prime y. Okay? And either you've already looked at this and figured it out. If not, hey, that's what Desmos is for. So we have a fraction with -2 divided by -4. Look at that. Positive 1/2, because the 2 negatives cancel out. 2/4 reduces to 1/2. So it means our scale factor is 1/2. So our rule, what we're trying to find out here, what is the algebraic rule? The algebraic rule is kx, ky. Well, k is 1/2, so this is 1/2 x, comma, 1/2 y. And there is the answer. Not too bad, right? Okay, so let's try number 5 now. Same thing. Yeah, it looks really scary. It's a hexagon, tons of points. Guess what? We don't need to use all of them. Let's do q and q prime down here. Oh wait, where's my orange? Q and Q prime. Okay, well, Q prime is negative 9x, negative 9y. So negative 9, negative 1. Q is negative 6, negative 6. So we're going to follow the same steps. Here's x, here's y. We used y last time, so let's use x this time. I mean, guess it doesn't really matter for this problem because it's the same numbers, but whatever. So K is the no rule, not the on rule, no rule. New divided by original. Okay, new x is negative 9. Original x is negative 6. So another one for the Desmos calculator. Negative 9 divided by negative 6. Looks like 3/2. You don't change it into a fraction if that's part of your answer. K is 3/2. We'll just leave it as a fraction. So our rule is xy becomes 3/2 x, 3/2 y. And actually, I'm going to show you guys how to type this using the text tool as well. So like for those of you that don't really have a stylus, here's the equation tool. So we have xy becomes an arrow. We have the arrow right here. So this is 3/2. So here's the fraction button, the AB. So 3/2 x, comma, 3/2 y, close parentheses, and done. And I want this to be blue, so I can even select that, change the color back to blue, change the size, and there you go. So even if you don't have a stylus, you could still write the answer out that way. I think it's still pretty easy too. Oh, it's nice and legible too. Okay? So you're going to do the same thing for number 6. I want you to do that one on your own. So same steps. Pick 2 corresponding points. Right? Write out the coordinates. Step 2, use the no strategy. So you want either the y coordinates divided or the x coordinates divided. Just like what we did. And step 3, you want to write the rule as xy becomes kx, ky, where k is whatever the scale factor you just found. And that's our answer. Okay, last page. These are where we need to find the new vertices. Okay, so again, rehash the rule. xy is the original coordinates. And then your new coordinates will be kx, ky. It's important. So number 7 says, triangle MNP is graphed on a coordinate grid with these vertices. It is then dilated by a scale factor of 9, so what are the new vertices? Okay, so I'm going to show way more work than is probably necessary, but I want y'all to really see the process. So I know that the points are already up there, but I'm going to rewrite them. This is 4, negative 2, N is 3, negative 5. P is 1, negative 3. So these numbers are just right here in the problem. I didn't have to do anything for them. To get our primes, so M prime, N prime, P prime, we take each coordinate and multiply it by the scale factor, which in this case is 9. So M prime's x is 9 times 4. M prime's y is 9 times negative 2. So same thing. N prime's x is 9 times 3. M prime's y is 9 times negative 5. P prime's x is 9 times 1. P prime's y is 9 times negative 3. So we literally just multiply everything by the scale factor. So that gets us our final answers here. Okay, 9 times 4 is 36. 9 times negative 2 is negative 18. N prime, 9 times 3 is 27. 9 times negative 5 is negative 45. Finally, P prime, 9 times 1 is 9. 9 times negative 3 is negative 27. And there is our answer. Easy peasy. Lemon squeezy. Okay, so you can see the steps to follow here. It's much less than before. You read the problem to identify the scale factor, aka k, and then you just multiply the scale factor to get the new vertices. Okay, let's look at number 8. Number 8 is worded a little bit differently. How do we figure out what the scale factor is? Because it doesn't, if you read the problem, it says a dilation of xy becoming 1/2 x, 1/2 y is applied to a triangle. The original vertices were a, b, c. What are the new vertices? Hey, it doesn't say anything about the scale factor, but look, right here, remember the rule is kx, ky, so this 1/2 is k. They're saying k is 1/2, so that's the number we're just going to multiply everything by. And they even told you in the rule right here, they're telling you this is what you need to do. 1/2 times all the x's, 1/2 times all the y's. So I'm going to show a little less work this time, because this is a little bit more similar, I think, to what you guys would be doing. Okay, so a prime is 1/2 times -5. A prime's y is 1/2 times +5. B prime's x is 1/2 times -5 again, and then the y is 1/2 times 10. C prime, 1/2 times 10 for x, and 1/2 times 0 for y. So this ends up with the points. 1/2 of -5 is -2.5. 1/2 of 5, 2.5. 1/2 of -5, -2.5. 1/2 of 10 is 5. 1/2 of 10 is 5. 1/2 of 0, anything times 0, is still 0. And that's it. Okay? Take a minute to finish off number 9 and 10. If you need inspiration, just look back up at number 7 and 8, because you're basically doing the same thing with different numbers. And that's it for dilations. Hopefully this was a nice breath of fresh air after rotations, because really all you have to do is figure out what the scale factor is and then multiply everything. That's really all there is to it. Alright, so I hope this video was helpful for you. If you have any questions, you know where to find me, and I will see you in class. Bye!